This machine was built to detect something no human ear can hear: black holes colliding in space. It is called LIGO, and it turned ripples in the universe into a signal humans could finally record. LIGO stands for Laser Interferometer Gravitational Wave Observatory. It is not one building, but two giant detectors in the United States, one in Hanford, Washington, and one in Livingston, Louisiana. Each site has two long arms arranged in an L shape, and each arm is 4 kilometers long. Inside them, laser light travels back and forth between mirrors with extraordinary precision. Why build something like this? Because space is not perfectly still. According to Einstein, massive events can send out gravitational waves, tiny ripples in spacetime itself. When one of those ripples passes through Earth, it slightly stretches space in one direction and slightly squeezes it in another. LIGO is designed to catch that tiny change. A laser beam is split in two, sent down both arms, reflected by mirrors, and brought back together. If both arms stay exactly the same length, the light lines up in a predictable way. But if a gravitational wave passes through, one arm becomes a little longer, while the other becomes a little shorter, and the pattern changes. The change is unbelievably small, far smaller than an atom, so LIGO has to isolate itself from vibration, traffic, weather, and almost every other source of noise. That is also why there are two detectors. If the same pattern appears in Louisiana and then, milliseconds later in Washington, scientists know they are probably seeing something from space, not a local disturbance. One of the most dramatic things LIGO can detect is a black hole merger. When two black holes spiral around each other, they move faster and faster, distort space more and more, and finally collide. That collision sends a burst of gravitational waves racing outward across the universe. LIGO does not hear this the way your ears hear sound through air. What it measures is a change in distance. But because that changing pattern behaves like a wave, scientists can translate the signal into audio. That is why people say LIGO heard black holes. In 2015, LIGO made the first direct detection of gravitational waves from merging black holes. It changed astronomy by giving us a new way to observe the universe, not only through light, but through motion in space-time itself. So LIGO is more than a machine in two quiet corners of America. It does not control the cosmos. It lets us notice that very far away, the universe moved.